Welcome back to Level 6 Math. I'm Mr. C, and today we're looking at Saxon Math lesson number 39, dealing with multiplying decimal numbers. Now, this is a lesson I don't know how I didn't get this when I was a kid, but I totally wish I had, because it makes math so much easier for the rest of your life. There's one big lesson or rule today that you're going to learn. It has to do with counting decimal points or decimal places that will make anytime you multiply decimals so much easier for the rest of your life. So let's dig right into it. Doris hung a stained glass picture in the front of her window to let the light shine through. The picture frame is 0.75 meters long and 0.5 meters wide. So how much of the area is covered? So we just need to multiply 0.75 by 0.5 and then meters times meters to find the area. Now when we do that, I want you to think about this first. We're just going to go through the process first and then we'll get into how to solve it. We could write it as a decimal number. So 0.75 is like 75 over 100, and 0.5 is like 50 over 100, which reduces to 5/10. Now we can multiply 100 times 10 and we get 1,000. 75 times 5 is 375. And then we could reduce that, or we could just write it to the thousands place as 0.375. And so we know that the picture covers 3.75 square meters. That's one way to do it, is as fractions. But we can also do it just by counting decimals. So the product 3.75 has 3 decimal places, and that the 3 is the total number of decimal places, meaning we went over 1, 2, 3 spaces, okay? When we found the factors, so 0.75 and 0.5, we see that those factors have 2 decimal places on that one, and 0.5 is just 1 decimal place on that one. So we have a total of 2 plus 1, which is 3 decimal places. Now, this is a cool thing. I wish I'd known this before. 2 plus 1 is 3, and that means the answer is going to have a total of 3 decimal places. And so you can just count those up. So we don't have to change 0.5 to 0.50 and multiply 0.50 by 0.75. If we did, then we'd have 4 decimal places, and we'd have to extend 1 more decimal point, which in this case would be 0, but we don't need that, it will go away. So what we can do is just 75 times 5, you don't even have to write the decimals in there. If you remember that they're part of it and just count them up before, there's going to be 3 total decimal places. So we're just going to take 75 times 5, and our answer is 375, and then we just count over 3 places, 1, 2, 3, and we get 0.375. That's it. It's so cool that this works. All right, so when you do it, you're just going to multiply your 2 numbers and then count the number of decimal places in each number, 2 on this one, 1 on this one, and then count over the total of that. 2 plus 1 is 3, 1, 2, 3. And then you can put a 0 before if you want. Anytime before there's a decimal, you can put a 0. All right, so let's do 25 times 7. Again, you notice I said 25 times 7, not 0.25 times 0.7, because what I'm going to do is I'm going to count even before I start. 2 decimal places, 1 decimal place, that's going to be a total of 3. So I can just do 25 times 7 and then move over 3 decimal places. So 25 times 7 is going to be 175, and I move over 1, 2, 3 decimal places, and I get 0.175. It's so awesome, okay? We multiplied 0.25 by a number less than 1. Oh, it's saying how could we have predicted the answer to be less than 1? Just multiply 0.25 by a number less than 1. Yeah, we could do that. Simplify 2.5 by 2. So again, it's going to be 2.5 times 2.5. That's going to be 1 decimal point and 1 decimal point, so it's going to be a total of 2. So I just take 25 times 25, and then I move over the decimal place twice. It gets me 120 or 125 plus 50 on the second row. Gives us a total of 625, and then I move the decimal over twice. 1, 2, 6.25. Awesome. Okay. Why 6.25 a reasonable answer? Well, we can think about what I usually do when I have things with whole numbers. Is I just think, what's 2 squared? 4. What's 3 squared? 9, because that's the higher number. What's somewhere between 4 and 9? About 6. So we know that our answer is going to be close. Okay. A mile is about 1.6 kilometers. Marie Cruz ran 3-mile cross-country race. About how many kilometers did she run? So if we take 3 miles and times it by 1.6, we're just going to be 16 times 3, and then move over 1 decimal place. 16 times 3, move over 1 decimal place, 4.8. Awesome. So 4.8 kilometers. So in a 5K race, it'd be slightly more than 1.6. It'd be like 1.61 or 1.62 would be 5 kilometers. That's it. That's your lesson. Good luck.